Okay, let's spend a little bit of time figuring out how to solve an inequality. Now let's think back a little bit. When we solved an equation, do you remember what happened at the very end? You had a value, right? You figured out the one value for the variable. And we could actually say, okay, well that variable was worth that amount. Done. Well, then we checked our answer, but other than that, we were done. Solving inequalities is a little bit different because we're actually trying to figure out what is the least or the greatest amount of things that value could actually be, okay? In other words, I'm not just gonna have one number. I mean, I'll have one number pop out of the inequality then once I've solved it, but it doesn't just represent one number. That number that I get, depending on which way my sign is pointing, will be either the beginning or the biggest, or the greatest, or the end, okay? Let me show you what I mean. This right here is a nice equation that I can solve and get one value for x. I don't know what x is yet. This is our mystery number, right? So we attacked this many different ways. We put things on a balance, we did backtracking, but most importantly, and the one we're gonna use today, is we used the inverse operations to figure out how to get x by itself so that we would know what it's worth, right? Let's do it real quick, just as a nice refresher. I know I want x to be alone, which means I'm gonna start with this plus 3, right? And to get rid of this, to get it away from x, I need to subtract. I need to add its inverse, or subtract. 3 minus 3, that works. But make sure you do the same thing to the other side of the equal sign, right? Always. I haven't done anything to 2x, so we'll bring it down. 3 minus 3 is 0, so nothing goes here. And 15 minus 3 is 12. Good enough? Now the only thing I need to do is get one of these x's. In other words, I'm dividing this x by 2, or this by 2, because I only want the value of one x, not two x's. Right now, 2x's equals 12. So what is just 1x equal? Divided by 2, and you'll be able to see it very clearly. So in this case, this equation shows me that the value of the unknown is 6, and only 6, okay? The mystery number that we were thinking of was 6, and that's it. Now let's do inequality and see what happens. What if I change the equal sign to less than? Think about what that means real quick. What does it mean to say that 2x plus 3 is less than 15? That basically means that now I don't have a nice balance, right? Now what this is saying is that this side has to be heavier than this side, because 15 is worth more than all of this. So whatever x comes out to be has to work with the rest of the stuff on this side of the inequality to become less than 15. All right? But here's the nice thing. For the most part, the rules are the same. I'm going to isolate x using the same process that I always have been. The only time it's going to get a little weird is when we start, is if this leading number right here is a negative, and we'll get to that later. Don't worry about that right now. But for now, let's get to work isolating x and see what happens. So let's just do the same thing we did a minute ago. Okay, get 3 out of the way there. And that gives us 2x is less than 12. And then divide by 2. See what happened? X is not 6 anymore. X is now less than 6, right? So what is x? Well, that's a little tricky. The correct question is, what's the biggest number that x can be? Or the biggest integer that x can be? Or it can also be, what number can x not be? Well, it can't be 6, and it can't be anything bigger than 6. It can be anything smaller than 6, okay? If I put a 1 in here, would that be a true statement up here? 2 times 1 is 2. 2 plus 3 is 5. Is 5 less than 15? Yes, indeed. Okay? Now we're not quite done yet. Yes, this is good. Now we know that whatever x is, it has to be smaller than 6. But one of the very important things that we've got to make sure that we keep doing, excuse me, is knowing how to model this. So let's put that on a number line. And again, you have pre-made number lines, you lucky. So pull one of those out. And you might actually be able to put several examples on one. Now, some of my numbers are going to get a little big, but we'll see. I'm going to make a number line in a minute that actually has numbers that are too big for us to scale our number line like this. But we'll get to that. X is less than 6. So if I want to mark 6, should it be an open one or a closed one? This is not x is less than or equal to 6, so I'm not including 6 here. This is going to be a nice open mark, right? And I'm looking for all numbers that are smaller than it. So my number, or my graph line, is going to go to the left to cover all numbers smaller than 6. And what that means is in the original equation, you can pick any number that's smaller than 6, and it will make that true. You will always come out with a true statement. Any numbers that are bigger than 6, try throwing in a 10 and see what happens. You're not going to get a true statement. Look at the equation in your journal. If I picked 10, 2 times 10 is 20, right? 20 plus 3 is 23. Is 23 smaller than 15? It's not, right? So it has to be smaller than 6. And that, in a nutshell, is basically what an inequality is, all right? And an inequality statement. Let's try a little bit of problem solving with this and see what happens. And remember, I'm looking for a couple of words, and they are very closely related to greater than and less than, and that is greatest or least. Let's start with one of these, okay? Let's say, my wife the baker. My poor wife. It takes her, let's say she's going to bake some cakes. And no, I'm not going to use T. She's baking some cakes. I'm going to use C for the number of cakes that she can make. Okay? So C in this scenario, in this word problem, is going to represent the number of cakes she can make. And the question is going to be, if she has a certain number of hours, what is the greatest number of cakes she can make in that time? Okay, so here's the deal. It takes her 2 hours per cake. All right, so I'm going to write that as 2C. 2 hours per cake. That right there shows how long it takes to make a cake. How long it takes to make any number of cakes. If she makes 1 cake, 2 times 1 is 2 hours. If she makes 5 cakes, 2 times 5 is 10 hours. So this is how many cakes she can make. Got that so far? Now, she's already made 3 of them. Okay? So it's gonna take her 2 hours to make any number of cakes, but she's already made 3 of them. All right? How long is it gonna take? Oh, not equals. How many cakes, what's the biggest number of cakes that she can make in less than 9 hours? Or in 9 hours or less? Let me rephrase that. So I'm gonna read this from left to right one more time. And I actually made an error with this number, so I'll repeat myself in a second. But how many cakes can she, what's the greatest number of cakes she can make in the time that's allowed to her? It takes 2 hours per cake. Okay, so each cake is going to take 2 hours. She's already been there for 3 hours. See, I misrepresented that before. This is time. 2 hours per cake, plus she's already been there for 3 hours. Okay? And this is the most time she's going to work. She's working 9 hours today. All right? So all of this cake making right here needs to take 9 hours or less. less than or equal to. Want me to say that again? I'm going to say it again. All of these things right here on the left have to be less than or equal to her 9-hour shift. She's already been there for 3 hours, okay? It's gonna take her 2 hours to make 1 cake. So how many cakes can she make by the end of her shift? In other words, what's the greatest number of cakes she can make before she leaves? Let's go ahead and solve this inequality, and then we'll see if our answer makes sense. First of all, I want C to be by itself. Let's get rid of this guy first. I get rid of a plus 3 by its inverse operation, and the same thing to both sides, right? This gives me 0, so the only thing left on this side is 2 times C is less than or equal to 9 minus 3 is 6. Okay, so if 2C's is equal to or less than 6, then 1C is less than or equal to 3. Now what does this mean? Okay. Let's look at this one more time. I know you're probably getting tired of me saying this. It takes her 2 hours to make a cake, right? She's already been at work for 3 hours. Her shift is no longer than 9 hours. So what is the biggest number of cakes she can make? Right here, we have C being less than or equal to 3. What this statement is saying is that if she stays there for the whole 9 hours, that she will be able to make up to 3 cakes. The greatest number of cakes she'll be able to make is 3, okay? Because number of cakes is less than or equal to 3, right? So that could mean she made 3 cakes. It means she made 2 cakes. It could mean she made 1 cake. It could even mean she sat there for the rest of her shift and made 0 cakes. That's what this means. This is not one number. This is not, oh, she made 3 cakes. This is she made 0, 1, 2, or 3 cakes. All right? Could she make negative cakes? Mathematically, no. You could imagine her like looking at the stock around the store and eating cakes. And then she's making negative cakes because now she owes the people cakes. So yeah, I guess that would make sense. If she just started eating all the cakes in the shop, then she'd be in debt. It would be a negative number. But let's not get crazy. The fact is, this answer does not equal just 3, okay? Keep that in mind. If I were to put this on a number line, it would include that number, it would include that 3 cakes, and then the number would, or the line would go to the left, infinitely. Let's try one more, just to make sure this is kind of clear. And then I'll give you a chance to play around with some exercises afterwards. Let's say that me and my friends go eat, and it's me and a bunch of friends, but only a couple of us brought any money. And we went to McDonald's. Not everybody has money, so I want to know how many people can I feed. All right. A value meal M is the number of meals that we need, okay, or that we have. Each one of these meals is $5, okay? So how am I gonna write $5 per meal? If M is a meal, or the number of meals, and they're each $5, that's just multiplication, right? $5 per meal. That's what that means. This could be any number of meals. Once I figure out what that number is, I multiply it by 5. That's how much I'm gonna have to pay. Now, this plus mine, I already paid for my meal, okay? So this right here is only gonna be my friend's meals. Here's mine, I already know I'm paying for mine. That's a given, that's a starting point, okay? Now I need to figure out how many of my friends need to eat or can't afford to pay for their meal. The problem here is, guys, I only brought 35 bucks. So I'm gonna have to compare how much all these meals are gonna cost, or how many, if I put in a number here, how much is this gonna cost, and how does that compare with the 35 bucks I just brought? And keep in mind that all of this has to be less than or equal to how much money I have. So from left to right, this means the number of meals times the price of each meal. If I figure out how many of my friends I can feed, this will tell me how much my friends cost, plus my meal already that I paid for, has to be less than or equal to $35 because that's all I have. That's all the money I have, guys. The question here is going to be, what is the greatest number of my friends that I can feed? For M. What's the biggest value that M can be? All right, so let's figure that out. Let's get this 5 out of the way. Remember to do the same thing to both sides. This is 30 over here. And everything that happens now has to be less than or greater, or less than or equal to 30. Here we can multiply so we can figure out what M is all by itself. 30 divided by 5 is 6. And I have M is less than or equal to 6. Okay? The one thing I really want to emphasize one more time when it comes to inequalities like this and you're solving them, remember that the process is exactly the same as what you were doing for solving equations. Okay? Don't get confused and think, what's different? What do I have to change? This part right here, nothing. The only thing you really need to do is look at this situation and then look again at this situation and say, what does it mean? All right? What does M is less than or equal to 6 mean? First of all, this time I'm including 6. So what this means is that the number of value meals that I can buy at most is 6. Okay? Can I buy fewer than that? Well, I can. I mean, let's say my other friend takes care of most of them and there's only 4 people left who need meals. Is 4 less than or equal to 6? Sure. So this statement right here means that I cannot feed any more than 6. I can feed 5. I can feed 4, 3, 2, 1, or 0, right? Okay. There's that. Talk yourself through these. Really get an idea of what it is that's going on here, okay? Now there are word problems in the exercises underneath. I want you to read through the word problems, think about what's going on and how they fit in here, okay? In general, what you're gonna see is there's a certain total amount of something, and what you need to do is figure out what's the greatest or the least number of this that can happen, okay? And look for starting points too. Is there something that's already been paid? Is there already something that's been decided? Is there already something that's happened? Because that's a known. The unknown is usually how many of something or how much of something is gonna happen next, okay? Try those exercises underneath this video. I'm gonna meet you in the exercise video underneath and we're gonna go through those together to make sure that we're not totally lost, okay? So I'll see you in a little bit.